Welcome back to Wickerson Studios. My name is Michael Wickerson, and I am grafting, just grafting single lines and checking the slope on those and trying to find a y-intercept. What I have here is also shifting up the expression node into the Python node for those that actually want to start scripting and not be so dependent on the I think it's called Virgin Python or Vanilla Vanilla Python. What's up here on the ribbon tool and what you're using. So if I go out of here, I think I've typed in some more data that I didn't have before. So maybe just a little theory behind what we're doing. It's pretty simple. The point slope equation of a straight line is y equals y1 plus m at x minus x1, and this is called the point slope form of the equation for the straight line, useful for studying tangents, which will come in later when we get into differentiation and integration. A horizontal line through P1 has slope 0 if the equation y equals y1, and a vertical line through P2 has an infinite slope if the equation, I think at P1, if the so the equation if x equals x1. And equation comes in the form a times x plus b times y plus c. So you solve for that and you get this equation that should be familiar with you from mathematics, but you'll be using the expression node and Python node to solve for y from that equation. And that's the linear equation provided that a and b are not both 0 and the slope is negative a over b otherwise. The two lines are parallel if they have the same slope, and they're perpendicular if they have a slope of -1, which is very interesting information. Other forms of the equation which are interesting are the slope y-intersect, which we solve for as y equals mx plus b, and this is a straight line with slope m and y-intercept b that is as it passes through the point 0b. And the two-intercept form, which will come from possibly circles and ellipses, will be x divided by a plus y divided by b equaling 1. And this line is has x-intercept and a y-intercept b as it passes through points a, 0, and b at 0b. So we'll get into that, but let's just jump into the script a little bit and see what's going on. I definitely have my grid that I was using before. It's pretty simple. It's just a little simple script for my XY real lines in the horizontal and vertical directions. And what I have here is I basically set up four parameters, and should probably call this one x, even though it's solving for all the x's. I'll just change that to x. But I have my a, b, and c that will solve the equation we spoke about earlier. And I produce a range of forms, and I keep my numbers very small. I can extend this out, and I can make it small, but I think it works somewhere between -5 and 5. And I make it so it balances in the middle, so it's easy to find the middle point because that will be x at 0. And if I find x at 0, then I can know the y-intercept. So I'm using that to my advantage. A, B, and C, and the constant C are what I play with, and I had to crank I keep my A and B pretty small. You see that rolls and that moves up and down to positive and negative, so positive slope, negative slope. And then I can also adjust the slope by changing B factor, which has a play on it. You can push that into negative if you want. And then C is the constant that moves that entire line linear equation up and down. So that's pretty simple. Now, what I did initially was I said, well, let's use the expression node and just type in solve for y out of that equation, a squared plus b squared, by plus c will equal y or equal 0, and then we solve for y. And that's going to be negative parentheses a times x plus c over top of b. And that should be a very familiar equation that you've seen, maybe not written in that way. And I solve for a line, and that's basically how I get the slope of that line and solve for that. I solve for it by 2 points and build a line between it, so at the start and end of that line. So not too hard, but I don't need that line. So I could take that and say, let's make that disabled. And then let's only run it into a Python script. And the Python script is exactly what the expression node did, but you're writing your own. And we're solving for the points at the ends, and I'm producing a line between the endpoints of that. And I used an explode tree to get at that by grafting it. There's just one way of doing it. You use flat, and you could use a whole bunch of tools in the set tools to figure out how to get at that list and play it off. But here's my equation in there. What I did afterwards was fairly simple, just some visuals of putting, I believe, the y over the x over here. It's kind of hard to see. The y over here turns blue. Pretty small text. The equation of what we're solving for, negative a times b plus c, all that negative, or you could leave it as negative a times x minus c but as long as that's in parentheses divided by b, you're going to end up with solving for y. And then I've got the y-intercept, which is a very interesting tool, which happens at 0.5 on the curve, and you can use the evaluate curve. So I'm using a lot of node components in the Grasshopper vanilla ribbon tools to solve for this. And then I also thought, well, let's just use the same tool and solve for any point on that line and end up seeing what the x and y would be anywhere on that line. And that data is changing. It's a wonderful little tool to get started with. You can grab all the visuals at the end, grab your data, and know what's going on. But let's jump into that Python node and see what that easy script is. And it's exactly what was written in the expression node. And I actually did this. I put in a kind of exception so I could solve for it. I just said if b is not equal to 0, because I don't want it to be equal to 0. So you could say if b is not equal to 0, then y will solve for that equation. And then else, it's going to provide an error by saying divided by 0 error. So if I actually brought that down and took a look at that node here, it's solving fine here. It doesn't say anything. But if I end up putting b at 0, so let's follow that back up, and let's put that down to 0. And let's actually set on a snapping at 0, so it's easy to get there. Let's have that snap to 0, and then you'll see it errors out, and you're not getting anything, but it doesn't cause a default. It just produces here divided by 0 error, and it comes up twice just because I have 2 points on x that I'm actually solving for. So it's a little clumsy script. It could be optimized a bit, but that's a nice little exception rule of what you're writing in your Python node. Of course, you're not getting that really with the expression node. So I'm trying to get people programming in Python for Grasshopper Canvas in the Rhino 3D viewport, and using very simple exercises to do so. So once again, there's our full graph. I believe if I took it on here, where's my data? What did I do? I think I brought back an old script there. What did I end up doing? Oh, of course, I have it set to 0, and as long as it's snapping to 0, I don't get anything. So I can bring that back down as long as I'm not dividing. And it's interesting how it comes in the top and goes off the bottom. I thought that was kind of nice, kind of playing off infinity. It's not something you're really going to explore in math, like on graph paper in school, in high school, or early days in university, but it is interesting to play with that. Once again, you can extend that out, moving above and below the x-axis, and you can just play around with your slopes and a positive and negative. Sometimes I like a negative slope because I'm more excited about a negative slope because it seems to be rising. I don't know. I think backwards to most people. I would think that should be a positive slope and the other one should be negative, but that's just where I'm wrong. Anyhow, hope you enjoyed it. I'm enjoying this. I'm going to go on graph some simple movable circles and play them off the same type of equation and start working with squared so I can get that double points at the x-intersect. And I'm also going to play with a parabola to start where you can end up with none if the parabola starts above the x-axis. So thanks again for watching. Michael Wickerson at Wickerson Studios, single variable calculus. And when we're done this next exercise, we're moving right into functions, and I'm going to have to get into my my scripts, and I'll be using Python, hopefully some downloads through Python remote node to end up using a thing called LaTeX, which converts a lot of really nice writing into LaTeX form in Jupyter notebooks. I'm not sure if I'm going to be able to do that, but I'm excited. I'm always looking ahead, always challenging myself, and I hope you guys are all doing the same. Thanks for watching.